Hello everyone. All right, it's the last one for the week, so let's try to make this baby short and sweet. All right, how's that sound? So this is Unit 1, Day 9, Slope and Equations of Lines. Okay, so a few lessons back, I asked you guys to use the slope formula. If you guys recall, it looks like this, y2 minus y1 for x2 minus x1. This is used to find the slope between 2 points. Again, your points are x1, y1, and x2, y2, whatever those may be. This particular lesson, we're going to be finding the slope, but then also finding the equation of the line itself. Okay? So in the coordinate plane, the slope of a line is the ratio of change along the y-axis to the change along the x-axis between any 2 points. Okay? Hence the change in y over the change in x. We like to call it, though, rise over run. Okay? The slope m of a line containing 2 points with coordinates x1, y1, x2, y2 is given by this formula, which I already demonstrated up there. Okay? So, down below it says, find the slope of each line. All right, we can do that. So this is -1 comma -2. This is 3 comma 3. Okay, so I'm going to zoom in here. All right, so I'm going to label this guy x1, y1, x2, y2. And then set up my equation. So y2 minus y1 over x2 minus x1. And I'm just going to substitute those values I already have labeled above. So -2 minus 3 all over -1 minus 3. All right, so we're going to get, now you're looking, you're like, ooh, a bunch of negatives here, right? We still end up with a positive slope. So this becomes a -5 over a -4. Remember, if they're both negative, you keep the sign and just add them. And so -5 divided by -4 is just 5 over 4. So let's see if we're right, though. All right, so I'm going to start at J. I'm going to go up 5, so 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4, and beautiful. All right, we have found the correct slope. Okay, so let's go over to the next one. All right, now I shouldn't have to take this slope, but I'm going to do it just for learning purposes, okay? But there's something special going on about this line here, okay? And I'll write the word up there, Vux, and see if you recall. All right, so anyway, let's keep going. So we're going to go 2 comma 1 is that one, and this is going to be 2 comma -4. All right, so let me just label this guy. We'll call this guy x1, y1, x2, y2, and so our equation is, y2 minus y1 over x2 minus x1. And if you haven't seen it already, what happens when you get 2 minus 2, you get a 0, and so this is one of our math no-nos, right? And so when you see something like this is called undefined, okay? And going back to this Vux problem, it says it's vertical, okay? Undefined is the slope, and it's always an x equals some number, okay? So this was a Vux problem, all right? And so we shouldn't be surprised we're getting a undefined slope because, well, it's a straight line up and down. All right, so I'm going to do a couple more here, and then we'll kind of skip to the good stuff. So this is x1, y1, x2, y2. So again, let me zoom in here so I can save some space. M is equal to y2 minus -2 all over x2 minus 6. So we get -5 plus 2, which is going to be a -3, and a -3 minus 6 will give me a -9, which can be simplified, and then you get a negative divided by a negative, which is a positive, so this becomes 1/3 is the slope there. All right, let's just do the one below, and we'll call this one a day here. So we'll call this one x1, y1, x2, y2. So our equation, y2 minus y1 over x2 minus x1. We fix that equal sign. Okay, so our y2 is 4 minus 2 over negative 3. Whoa, oops, geez, Eric. Uno momento, had a moment. So y2, negative 3, minus y1, which is 2, for x2, which is 4, minus x1, which is also 4. Uh-oh. I'm not gonna solve this one out because I know this one's going to be undefined because we get a negative 5 again over a 0. All right, which makes sense because if you look at our x values here, our x values are the same. Okay, so anytime you get 2 points where their x values are the same, okay, we know that's an example of a Vux problem or an undefined slope. Now going over to this one, okay, I'm just going to do this one for fun. If you notice, all right, our y values are the same here. All right, so it's kind of different than this one. All right, our x values were the same over there. So in this one, our y values are the same. So let's see if you can, see if that rings any bells here. But I'm not assuming anything. Let's just go through it. So m is equal to y2 minus y1 over x2 minus x1. So we get 0 over 7, which is just 0. So this is an example of a Hoy problem, right? Anytime you see 2 points that have the same y value, you got to think Hoy, right? It's a nice horizontal line, and its slope is 0. Okay? All right. We'll skip 1b there. All right, so you may remember from algebra that an equation of a non-vertical line can be written in different but equivalent forms. Okay, so these should look a little familiar from last year. We got the slope-intercept form and the point-slope form. Okay, so the slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. All right, and the point-slope form is where you got x1, y1 is your point, and then m is the slope. Okay, so in order to find the equation of a line, we have to first find the slope and then plug one of our points into this formula here. Okay, and then once we get it into this form, then we can migrate back to the slope-intercept form. Okay, this one is just not simplified yet. All right. That's it. That's the only difference between this one and the one above. Is the one up above is simplified. This one we still need to distribute and bring our constant over to the other side. Okay. Well, we are not going to make it through all those, are we? Oh, okay. The homework problems are right here. Okay. Phew. I was like, there's no way. All right. So those are homework problems. So we have just a few more to go. All right. So it says write an equation in point-slope formula line with a slope of a negative 3/4 that contains the point negative 2, 5. Then graph the line. Okay, so in this example, they have already done it for us. So here's our point-slope form. Okay, we just substituted in our slope for m, and we plugged this in for x1 and y1. All right, and by doing so, you are left with this right here. Okay. Now it says to simplify, all right, if we want to simplify this thing, okay, we'd have to distribute that negative 3/4. So by distributing that negative 3/4, we get a negative 3/4 x plus, all right, I don't know what that is off the top of my head. I think it's a negative, well, not plus, it'd be minus 6 over 4. Okay, remember when you multiply fractions, negative 3/4 times 2 over 1, you just multiply across, so we get a negative 6 over 4. And then add the 5 and the 5, so y is equal to negative 3/4 x. Now I got to add those darn things. Okay, so negative 6/4 plus. What is that noise? Okay, I guess that's my laptop. It's just making some noise here, guys. It's throwing me off. All right. So negative 6/4 plus 5/1. All right, so I'm going to have to come up with a common denominator. So I'm going to keep this guy, and I'm going to multiply the top and the bottom by 4. So I get 20 over 4. So it's a negative 14 over 4. All right, which can be simplified even further to a negative 7 over 2. And there is our equation in slope-intercept form. Okay, it didn't say to do that, but I just wanted to show you how do we get from here to here. Okay, let's do the last one here, and we'll call it a day. So write an equation in point-slope form. All right, so I'm going to change that to slope-intercept. Okay, slope-intercept form. So write an equation in slope-intercept form of the line with slope 4 that contains negative 3, negative 6. Then graph the line. Okay, well, that was awful nice of them to give us a slope that's not a fraction. Okay, that's pretty cool. All right, so let's put it into that formula. So we're going to go y minus y1 is equal to m times x minus x1. All right, and so in this case, our m is 4. Our y value is a negative 6. And our x value is a negative 3. All right, so let's simplify this, make this look nice. All right, so a negative, 2 negatives in a row makes that a positive. We got 4 times x plus 3. All right, I'm going to distribute the 4. So I get y plus 6 is equal to 4x plus 12. Subtract 6, and we get y is equal to 4x plus 6. And that is the equation of a line with a slope of 4 that contains the point negative 3, comma 6. Okay, so we had to start at point slope form in order to get to slope intercept. Okay, and then the rest is for homework here, guys. This is all you got for homework, all right? Not very big, okay? So anyway, you might need to do this on a separate sheet of paper, all right? But regardless, all right, good luck, you guys, and hopefully that was nice and short for you.